Hello guys, in this playlist we will be discussing the entire 2024 electrical engineering paper of the assistant engineer post of Assam Public Health Engineering Department. If you have not subscribed to our channel yet, click on the subscribe button below and don't forget to like this video. Alright, so now this paper consists of 100 questions, okay? And this playlist will contain 20 videos where each video will consist of 5 questions. In today's video, we will be discussing the first 5 questions. That is from question number 1 to question number 5. So let's move on to the first question. What does it say? Floating battery systems are widely used for. We have 4 options. This is a purely theory question. So you just need to mug it up. The answer is all of the above, as you can see. So where are floating battery systems used for? In power station, energy lighting, telephone exchange installation. Okay, now let's move on to the second question. The Thevenin voltage and resistance of the given circuit seen from terminals A and B are. Okay, so this question is based on Thevenin's theorem, and we have 4 options to select from. So the circuit is given. We have one current source, one voltage source, and 2 resistors. So now we will be applying Thevenin's theorem to solve this problem. That is, find out the Thevenin's voltage and Thevenin's resistance. So at first we will find out VTH, which is defined as the open circuit, voltage between terminals A and B. We will name the first node as P. Okay, just ignore this tick, okay, for the time being. Let us focus on the solution, and then when you are able to solve by yourself, only then come back and see the answer. So now moving on to the solution. We will name the first node P, like this is the first node. We will name it as P, and the lower node O, And then what we are going to do, 1 ampere current flows from the current source and gets divided into 2 branches. See, this is 1 ampere current, and it gets divided into 2 branches, right branch, left branch. So let us assume I1 current got split into the right branch. We will assume I1 current is getting split into the right branch. So remaining 1 minus I1 current will flow into the left branch. It's basic common sense. 1 ampere current was flowing. I1 goes into the right branch. So what will remain? 1 minus I1 current. So it will move on to the left branch. Now the voltage drop across right hand side, that is the 2 ohm resistor, will be equal to the voltage drop across left hand side, that is the 2 ohm resistor and 2 volt voltage source. So we will equate the voltage drops on both sides, like voltage drop on this side and voltage drop on this side. We will take the sign for voltage drop as negative, like very basic. See, when the current will flow through this resistor, obviously there will be a drop. It is moving from right to left. So positive to negative. Current flows from positive to negative terminal. So the direction will be, we will consider it from positive, negative. And then when it will be having a flow from positive to negative in this voltage source, there will be a drop. We will consider a voltage drop here, a voltage drop across the resistor and a voltage drop across the voltage source. So that those voltage drops will consider negative. Hence, the voltage drop on RHS will be minus 2I1. See, voltage is equal to current into resistance. What is the current flowing across here? I1. What is the resistance value? 2 ohm. So I into R. I1 into 2. So voltage will be equal to V equal to 2I1. Look here, V equal to 2I1. But we see a minus here. Why do we see a minus here? Because as we have discussed just now, it's a resistor, there will be a voltage drop, and when there is a voltage drop, we consider a minus, negative sign. So hence minus 2I1. Okay. Now voltage drop on LHS will be minus 2 1 minus I1 across 2 ohm resistor and minus 2 volt across the voltage. See, here voltage drop is occurring at two places. First this place and second this place. Here voltage drop equal to I into R, current into resistance. What is the current flowing here? 1 minus I1. What is the resistance value? 2 ohm. And it is a drop. So minus 2 into 1 minus I1. This one. Minus 2 into I minus I1. And here the voltage drop is, it's clearly written 2 volt, but it's a drop. So minus 2. So this part is the LHS and this part is the RHS. So we are equating both the sides. The minus we take common and clearly cancel it. We are left with this equation. We solve this equation and we get the value of I1 to be equal to 1 ampere. So now Thevenin's voltage, that is the voltage across terminals A and B, which is the voltage drop across the 2 ohm resistor. We are supposed to find the voltage drop across VAB, right? And this voltage drop across the 2 ohm resistor. So it will be the voltage drop across this 2 ohm resistor. Voltage drop across this 2 ohm resistor, what is it? I into R. What is I? I1. And what is R? 2. We have just now found out the value of I1, which is 1 ampere. So 1 ampere into 2 ohm is equal to 2 volt. So we have half of the answer, that is Thevenin's voltage is equal to 2 volts. Now for the second half of the answer, we need to find the RTH. We need to find out Thevenin's resistance, RTH. Now to find out RTH, we need to open circuit. We need to open circuit the independent current source and short circuit the independent voltage sources. Now, when we say independent current source, what do we mean by it? We call it independent source because the 1 ampere current source is not dependent on anything else. Let's say, suppose in place of 1 ampere, the value of the current source was X volt. Okay. So what would happen? So suppose in place of 1 ampere, in place of this, we had a term named X volt. It would no longer be independent. It would be dependent on voltage, hence becoming a dependent current source. And the same goes for independent voltage source as well. So after doing this, after doing both these steps, whenever there is an independent current source, open circuit it, and whenever there is an independent voltage source, short circuit it. So after doing this, both of these, our circuit will look like this, will look somewhat like this. We will place things a little properly and will look somewhat like this. See, here there was a voltage source. What did we do? It's an independent voltage source, so we short circuited it. And here there was an independent current source, so we open circuited it. This is all we did, and rest remaining it's same. This is the technique we use for finding out Thevenin's resistance. So when we arrange things a little bit properly, these two are not different things. These are the same things. They've just arranged it a little properly. We get this. Okay. So both the 2 ohm resistors are in parallel now. It's in parallel combination. So our equivalent resistance will be resistor 1 into resistor 2 divided by resistor 1 plus resistor 2. And if we solve this, what do we get? 1 ohm. And that is the answer. Or we can do one more thing. Since the value of the resistances are equal in parallel, we can also do this thing, value of resistance divided by number of resistors, which will be 2 ohm divided by 2, which is equal to 1 ohm. So either way, we are getting the answer to be RTH is equal to 1 ohm. Hence, we have found out the value of Thevenin's resistance to be 1 ohm. So we have our answer now, which is 2 volt and 1 ohm, which is option A. This is the correct answer. Okay. So we have solved the question 2. Now let's move on to question number 3. In this question, we need to find the value of V. What is the value of V? Okay, in this circuit, we will observe the, okay, 5 ohm and 2 ohm resistors are connected in series, and we know current flow stays constant through a series connection of resistors. Hence, the same 2 ampere current will flow through both the 5 ohm and 2 ohm resistors. The small outer loop will be ignored as current flow requires a loop to flow, which is fulfilled by the bigger loop. So now the voltage drop across 5 ohm resistor will be what? What is voltage drop? Current into resistance. What is the current flowing through your 2 ampere? Resistance value 5 ohm. So across 5 ohm resistor will be 2 ampere into 5 ohm is equal to 10 volt. This one 5 into 2, 10. We see a minus here. Why? Because we have discussed in our previous question as well, whenever there is a current flow through resistor, there is voltage drop, and then we use minus. Okay, and voltage drop across 2 ohm resistor will be 2 ampere into 2 ohm. So this is one resistor. Here will there will also occur a voltage drop across this resistor as well, and it will be equal to the current 2 ampere into 2 ohm resistance. 2 into 2. There's a minus sign as well. Why? We have learned just now. The current is flowing in this direction. There will be a voltage drop here, and whenever there is a voltage drop, we consider minus sign. And here it's positive. Can you tell me why? See, the current is flowing in this loop, in this fashion, clockwise. So when it will flow clockwise, it is flowing from minus, negative to positive terminal. So the value will be positive. So now we have, by using KVL, the entire thing I said was KVL only. So basically we are writing it in KVL form using KVL. V minus 5 into 2 for this and minus 2 into 2 for this is equal to 0. So V, after solving this equation, we find the value to be 14 volt. So the answer is C, 14 volt. Where are the options? Yeah, C, 14 volt. Okay. Now let's move on to the next question. The Thevenin equivalent of a circuit operating at omega is equal to 5 radian per second has open circuit voltage equal to 3.7 angle minus 5, 15.9 degree volt ZO is equal to 2.8 plus J 0.67 ohm. At this frequency, the minimal realization of the Thevenin's equivalent. Okay, see, in this question, the Z0 value is given. This is the Z0 value, impedance value is given. The phase angle of Z0 is positive. So why am I focusing, emphasizing on this thing, positive? We'll learn why. See, for an RL circuit, that is a circuit where there's a resistor and an inductor. The impedance is given by Z equal to R plus J XL, and we know XL value. Reactance, inductive reactance value is equal to omega L. Z is having in this case a phase angle which is positive, which indicates lagging current. When in place of RL circuit, we have RC circuit, and when we are having RC circuit, the impedance is given by this equation, Z equal to R minus JXC. Can you see the difference? In RL circuit, we are using positive for the phase angle. But in RC circuit, we're using negative for the phase angle. For an RLC circuit, when we are having all three together, capacitor, inductor, resistor, the impedance is given by Z is equal to R minus J, XL minus XC. The phase angle can be positive or negative depending upon the values of the inductor and capacitor. Okay. Here the phase angle of Z0 is given, right? We have it given. It's positive. And from the equations we have seen, it is indicating an RL circuit. It's positive. And from the equations we saw, whenever there is a positive phase angle, the circuit is RL circuit. We can realize the given impedance using RLC circuits also. We can use all three components also. But since this question is particularly demanding minimal realization, it's particularly saying minimal realization of impedance, hence RL circuit will suffice. So the answer is a resistor and an inductor. I hope this is clear. Okay, so moving on to the last question of today's video. We have the question saying a complex current wave is given by I is equal to 5 plus 5 sine 100 pi t ampere. The average value will be, we have four options and we need to choose one from them. See, to solve this question, we have two methods. The first is a short method and the second is a long method. Let's start with the shorter one first. This is the given I value. This is one thing we should know. Average value of sine omega t and average value of cos omega t is always equal to 0. What is the justification for this? This is the justification, the waveforms. The waveforms of sine omega t, waveform of cos omega t. See, in one cycle, 0 to t, this is one cycle, this is one cycle, okay? So in one cycle, if we take out the average, half is positive, half is negative. If we sum this up, won't this cancel each other? And won't it would be left with only 0? That is what is happening. So this is the justification. In both the cases, the average values of sin omega t and cos omega t are 0. Okay, this is the shortcut. Like, see, if sine omega t and cos omega t values are 0, so here sine omega t, here omega is 100 pi. So this value will automatically become 0. So 5 into 0 will be 0. So 5 plus 0, 5. So the average value of 5 will be equal to 5. We'll straight away get the answer. That is the option D, 5 ampere. Now let's move on to the long method. Okay. In the long method, we go by the classic way of finding average value. I average will be equal to, we'll first, sum up this entire thing and then we will divide it by the time period, 0 to t. 0 to t, one entire period, cycle, one entire cycle. We'll take out the average of one entire cycle. See, if we need the entire, see, the current is changing at each point, So we need to integrate it, integrate the entire current from 0 to t. 0 to t integration, 5 plus I. This is the value of I. What was the value of I? I equal to 5 plus 5 sine. So this thing, I, we are integrating with respect to dt and the limits are 0 and capital T. I told you how we are getting 0 and capital T because we are considering for this one cycle. Here it is 0 and here where my cursor is pointing, it's capital T. One entire cycle divided by T, the time 0 to T. 1 by T will come out because it's a constant and we'll be left with 5T. Now how did we get 5T? We'll divide this. See, 5 dt plus 5 sine 100 pi t dt. It will get divided like this. So when we'll perform integration on first 5 dt, the 5 will come out and integration of dt will be t. So 5t. This is how we get. And then we will have integration of 5 sine 100 pi t dt. The 5 will come out and integration of sine 100 pi t is minus cos 100 pi t divided by 100 pi. So this is the second term comes from the integration of this term. And the limits will be there 0 to t. 1 by t, 5t. Okay, so now the limits we are putting it here. When we'll put the limits here, that is capital T, 5t minus 5 by 100 pi, that will come out and we'll be left with cos 100 pi capital T minus cos 100 pi into 0 will come in place of t. So it will basically become cos 0, which is this. Now we know the value of cos 0. What is it? 1. We need to find this value, cos 100 pi t. This is basically cos omega t, right? So omega is taking up the place of 100 pi. So we can write omega is equal to 100 pi. And we know omega is actually equal to something. And what is that something? That is 2 pi by t. We all know it, right? Omega is equal to 2 pi by t. So if we substitute this thing, in place of 100 pi, if we write 2 pi by t, it will become somewhat like this: cos 2 pi by t into t. T will get cancelled and we'll be left with cos 2 pi. The cos of pi, which is an even multiple, we have it as 1. The value we have it 1. So automatically this term will become 1. So 1 minus 1, what will it become? 0. So 5 by 100 pi into 0 will be 0. So we'll be left with 1 by t into 5t. 1 by t into 5t. So which will cut each other. T, or both the t's will cut each other. And the average value of I will be left with 5 ampere, which is the answer. So the answer is D, 5 ampere. Yeah, this one, 5 ampere. This is all for today. We will meet in the next video. Thank you.